All right, guys. We're talking about modeling linear relationships, and the first thing I want to do is do a just one example problem here for you. But before we do that, we need to discuss what modeling linear relationships is and how we approach these types of problems. Now, modeling a linear relationship just means that we want to be able to use a linear function or a function that graphs a line to describe a situation. And when we approach a problem like this, there are two forms of linear functions that we're really going to focus on. And the first is slope intercept form. This is one that you are super familiar with from your practices, intercept form in the last chapter. And hopefully you're comfortable using that one. Slope intercept form comes to us in the form y equals mx plus b. Now, previously we've discussed that this b here is your y-intercept, where the line crosses the y-axis, and your m here is the slope. And that's still true. That's still true for all of this. But as we're talking about word problems here and modeling linear relationships, there's a couple things that we want to note that are slightly key words, if you will, for these type of problems. If we see a problem and it has a rate, okay, or a rate of change. Remember, rate and slope are the same words. They mean the same things, rate of change. Some of the words that we might see that mean it's a rate is like per day or per hour or per game. Okay. And this y-intercept here for us means like an initial value. Okay. Initial value. We're going to call it an initial value. But some of the words that we're going to see that mean we have just a y-intercept is like one time fee. If it's something that I only do once. So if you only pay for bowling, if you only pay to get in the building $5 and then you pay per game, we're only going to charge that $5 once. That's how we're going to use slope intercept form. The other way that we have to choose between the two is if we might want to use standard form. In standard form of a linear equation, will look like this. It's our ax plus by equals c. So ax plus by equals c. Now, technically, to be in standard form, they would all have to be whole numbers, right? But in this case, when we're talking about modeling linear relationships, we're just looking for the variables to be on one side. Okay, so we're not so worried about the whole numbers in this case. But when we look at standard form, what some of these things really translate to for us is this is going to be like a total amount, okay, a total of some sort. And what we have to think about is, well, if we're totaling something, what does it mean to total? To total means you're going to add two things up. So the question becomes, what are we adding together to get to a total? So if we're trying to make money, maybe you work two jobs and you're trying to figure out how much you make in a week. So your total for 1 week would be how much you make in your first part-time job and the how much you make in your second part-time job. So maybe you babysit and work at McDonald's. So my first part here would be the money I make from babysitting and the money I make from working at McDonald's. And if I add those two together, I can find the total. So what we need to decide is these parts may also have like a rate attached to them. So this could be like maybe we're selling two things. Okay, maybe we're selling binders and notebooks. If we're selling binders and notebooks, I'm going to take the total I sell for a binder. So this will be an expression. And this will also be an expression. Okay, because we're going to be plugging in different things. Remember, it's like the number of binders or the number of notebooks that I sell. So we need to decide which form is going to fit our situation, and then we'll solve the problem to do that. Okay, so let's take a look at an example here. So I'm looking at number 1, and I might use some scrap paper here next to me. So if you have scrap paper, that's a good idea to have out. We're looking at a recycling center, and remember our steps, our order here, the steps we want to follow, the procedure is to first analyze the information. So what I want to do is I want to break down the important things, and I want to circle some of this important stuff that I'm given. Well, a recycling center pays 10 cents per aluminum can and 5 cents per plastic bottle. The cheerleading squad wants to raise $500. So here's what I see that's important here. I see that this 10 cents per aluminum can, and you can circle the can there if you want, and 5 cents per plastic. That's like 2 rates. And then I see that they want to raise a desired total of $500. So I see these kind of as like 2 rates, if you will. These are kind of both rates. And this is a total. So if I've got 2 rates and a total, it's looking like I'm going to want standard form. So now I need to write an expression for the first part of my total. Well, let's think about it. What is totaling to $500? The first thing that's going to total to $500, or is the first part of that $500, is going to be my aluminum cans. Well, how can I write 10 cents for each aluminum can? And what I want you to think about is, well, if you had 1 aluminum can, you would get 10 cents. How much would you get for 100 aluminum cans? Well, if you think about that, all you're doing is multiplying by that 10. So I can write an expression for aluminum cans as 0.10 times the number of cans. We'll call the number of cans A. Well, once we have that base idea down, we can use the same concept for plastic bottles, which would mean this would be 0.05 per plastic bottle. So P is our plastic bottle, the number of plastic bottles. So maybe we should write that P is the number of plastic bottles. I realize I went off your screen there. Sorry, we can go get it. There it is. It's the number of plastic bottles. And our A is the number of aluminum cans. And those are both my parts. So now I'll take my 2 parts and I'm going to add them together to get my total. So 0.10A plus 0.05P will be will be equal to my total. So I can say that my linear equation here in standard form, even though it's not whole numbers, we're going to say this is standard form right now, is 0.1, because we don't need that 0, 0.1 times A plus 0.05P. And we want to earn $500. We want to raise $500. Well, now what we need to do is we need to graph this. And in order to graph it, we need 2 points. Get 2 points. Well, the easiest 2 points to find in standard form are going to be our intercepts. And remember, that's where a line crosses an axis. So we'll plug in 0 for those points. So let's take a look at what this is going to look like for us. We've got this this standard form expression of 0.1a equal plus 0.05p. We want that to be 500. And what I want to do is I want to find my y-intercept. So to find my y-intercept, well, that's where x is 0. So I'm going to plug in 0 for what I see for x. And this is a plus sign here. Sorry, it's getting a little messy. Well, my A in this case, my aluminum cans, can either be my X or my Y, since we said A here instead of X and Y. Okay, so let's look at the graph they gave us to see if that clears anything up. Well, on their graph, aluminum cans is on the Y-axis. So their aluminum cans is their Y, and plastic is their X. So in our equation here, we're going to say that this aluminum is actually our Y, and this is our X value, okay? But we can decide that here in when we graph it too. So if I'm plugging in 0 in for X, I'm going to plug it in for P because that's the graph that they gave me. So what that means is I'll have 0.1A plus 0.05 times 0. And that'll be equal to 500. Well, 0.05 times 0 is just 0. So that goes away. That's just 0. So 0.1a equals 500. Because 0.1a plus 0, this is 0 here, would just be 0.1a. Well, then to get a by itself, we have to use our inverse operations and divide by 0.1. Because this is 0.1 times a. Now, another way to think about dividing by 0.1, it's the same thing as multiplying by 10. So I know that a here, the number of aluminum cans, needs to be 5,000. So I can plug in this point, my y-intercept will be 0, 5,000. Now we'll do the same thing to find our x-intercept, but we'll have to plug in 0 for a. So again, we're at 0.1a plus 0.05p is equal to 500. And then we're plugging in 0 for a. So 0.1 times 0, 0.5p equals 500. And we're taking the place of a. We're plugging this in for a. And this is going to be 0. Okay. Well, 0.1 times 0 is just 0. And 0 plus 0.5p is 0.05p. And then to get rid of that 0.05, we use our inverse operations, which means we must divide by 0.05. Now, dividing by 0.05 is the same thing as multiplying by 20, if you want to think about it like that. So I can multiply this by 20, and this will give me that my P is equal to 10,000. So this point would be 10,000, comma 0. So let's graph those 2 points and see what kind of information we can obtain from this function. So I've got 0, 0, 5,000. Remember, I had 0, 5,000. And this was my plastic cans, plastic bottles to aluminum cans. So my aluminum cans is my Y. It looks like this goes by 1,000, 1,000, 2,000, 3,000, 4,000. 5,000 would be right here. 0, 5,000 is right there on that line. And then I want to plot the other point, which was 10,000, comma 0. Well, this looks like it's going by 2,000 on the bottom here. 2,000, 4,000, 6,000, 8,000, 10,000. So that point would be right here. And then we can take a ruler or a straight edge, and we can draw a line to connect those 2 points. Because remember, it only takes 2 points to create a line. Now, there's a couple different ways we could do this. We want to answer part C here. And part C says, if the cheerleading squad collects 6,000 plastic bottles, how many cans will it need to collect to reach the goal? And remember, all of these points on this line will get us to our goal of raising $500. So if I sell 6,000 plastic bottles, that's right here. Here's my 6,000. I want to know how many aluminum cans I would have to sell. Well, I can use this graph here, and if I see that this point on this line is a solution, if I sell 6,000 plastic bottles, it looks like, just looking at this graph, that I'll have to sell 2,000 aluminum cans. So what we can say is that, well, maybe my picture's a little bit off, so we'll approximate it first, and we'll say the graph tells us approximately 2,000 aluminum cans. It seems like a lot of cans. But if we want to know for sure, if we want an exact answer, we can use our equation again. But this time, I want to plug in my number of plastic bottles. It's not 0, it's 6,000. So P in this case will be equal to 6,000. So we just plug in P for 6,000, or 6,000 for P, and then we solve. So I have 0.1a plus 0.05 times 6,000. I still want that to be equal to 500. Well, if we do that, 0.05 times 6,000 is 300. So I have 0.1a plus 300. Remember, we always want to simplify our equation as much as we can before we start. So this is still equal to 500. And now we want to solve for a. So to solve for a, we need to get rid of this 300. The opposite of adding 300 is subtracting 300, which means I would have 0.1a is equal to 500 minus 300. That's 200. And then I need to divide by that 0.1 or multiply by 10, whichever way you like to think about it, because this is 1/10. So we can multiply by 10 as well. And we do get that a is equal to 2,000. So our graph was actually pretty good here. We did get an approximate solution of 2,000 here, but our exact answer is 2,000. So we can say that yes, this is in fact exactly 2,000. And 2,000 what is probably the right answer. 2,000 aluminum cans. Always important not to forget your label. There's an example for you. Answer the questions as best you can. Thanks for watching.